Okay, so now we're going to look at patents and the role that patents play in the industry of and the development of 3D printing and additive manufacturing, which is very large. Patents play an enormous, very important, and crucial role in the additive manufacturing industry. So first of all, let's define what patents are, the different types of patents. There are three types of patents. Plant patents, which cover vegetation and hybrids. Design patents, which cover new and creative ways of making existing objects. And utility patents, which cover new, non-obvious, and useful machines. Okay? Obviously, 3D printing and 3D printing patents are not going to fall under the category of plant patents. So for 3D printing and additive manufacturing, we're left with either design patents or utility patents, depending on what you're trying to patent. Okay? So in separating and understanding which is more appropriate, the design patent or utility patent, we can say that an object's design, as in a design patent, includes its configuration or shape. Okay, the surface ornamentation applied to it, how it looks, the combination of configuration, shape, and surface ornamentation. Okay, those are the things that are covered with a design patent. With a utility patent, okay, we're talking about what the object does, how it functions, and how it is used. So that's a utility patent. Okay. If an object's configuration or shape results solely from its function, the design is not ornamental, and a design patent is inappropriate. So in that case, it would be a utility patent that would apply to it. Okay, so basically a design patent is when you're trying to patent the way something looks. All right, and a utility patent is designed for something, patenting how something works. Okay, so those are the broad differences between those two. A design patent can only protect an article's or an object's appearance. All right, design patents typically have a very narrow scope, limited to the patented design and any colorable imitation of it. All right, so most of our 3D printing patents and additive manufacturing patents are going to fall under the rubric of a utility patent. Okay, both utility and design patents give the owner the right to exclude others from making, using, selling, and offering to sell the patented invention in the United States. Now, that's a huge part of the patents and the role that they play in 3D printing and additive manufacturing. So let me state that again. When you own a design or a utility patent on an object, you control how the object is made, used, sold, and offered in the United States. Okay, so if you hold a utility patent for an object, you're the only one that can make and sell that object. All right, now those exclusions expire. Right, so a design patent is going to, you're able to exclude people from using your object that was patented for 14 years if it was patented with a design patent. Okay, so 14 years from the filing date. After that period, you do not own, or you can't exclude people from using or making that object. The patent has expired. Utility patents, on the other hand, are good for 6 more years. So 20 years in total from the filing date. All right. In most cases, patents are not renewable. So once you exit from that exclusionary period, right, 14 or 20 years, depending on what type of patent you file, once you exit from that exclusionary period, anybody can make that object. Okay. That thing that you invented, anybody can make it and sell it. All right, and that's going to be a crucial factor as we're going to see in the shaping of the 3D printing and additive manufacturing industry. All right, so let's keep going. What patents or what class of patents cover 3D printing? Well, patent subclass B33Y is a cooperative patent classification that covers additive manufacturing, i.e. the manufacturing of three-dimensional objects by additive deposition, additive agglomeration, or additive layering. For example, by 3D printing, stereolithography, or selective laser sintering. All right, so that is the subclass that controls, like if you're going to make a design patent or a utility patent, you're going to file for one of those. That's the subclass that you would file under. All right, B33Y. Okay, so let's move on now. So patents, as I said, played a huge role in shaping the 3D printing and additive manufacturing industry that we are in right now. Okay, we can see the growth of patents from right at the beginning, from Charles Hull and Dr. Kodama's start of 3D printing all the way through. Now this chart ends in 2013, but don't worry, I have charts that show later. But basically the point of this chart is to show the exponential growth. And yeah, this is really an exponential growth right here of patents. Okay. So we went from, basically just a couple of patents, 2, 3, 4 patents, whatever, to upwards of 600 patents filed in 2013. All right. Now, there's a reason why we have this explosion of patents, and we're going to talk about that later. If you're wondering why all of a sudden we see all these patents around 2009, 2010, and we're really ramping up, there's a very good reason for that. All right. Now, if we want to look at more recent numbers, these are the numbers from 2009 to 2020. And what's interesting about this is it also puts into play Chinese patents and British patents for this, so you can kind of compare. Notice the Chinese patents are really ramping up here. U.S. patents are always going to be higher than them because we have a little bit different of a industry than the additive industry that we would have that they have in China. Also, there's a different patenting process, in China. I don't think in China patents are controlled as closely as they are in the U.S., right? As exclusionary, right? Now, I would also like to point out, you'll see that there is a big dip right here. Of course, this is the dip that we would expect during a pandemic, right? So yeah, in 2020, right in the middle of the pandemic last year, there was a pretty sizable dip in patents. But other than that, we still see the exponential growth of patents year by year. Now, if we want to break down that subclass, that B33Y subclass for patents, into specific types of technology, then we could look at this chart. So in this chart on the y-axis across here, we have the different types of I don't want to say the different types of patents, but the different technology that the patents are addressing. Okay. So right at the top, we would expect that the broad categories of 3D printing and additive manufacturing, control or have the sizable share, the largest share of patents in their respective technology fields. All right. So we can see all the way out to 2020, there were 832 3D printing patents and 253 additive manufacturing patents. Then we go down this list and you'll see how broad these are. And what I'd like to point out is a couple of things. First of all, the very varied, I'm not sure whether that's a good use of the phrase, but the extreme variety of technologies that are now being applied to the 3D printing patent subclass, okay? All the way from tissue engineering, that would be, a biological type of technology, down to microstructure, and we have, microfluids. You'll notice that there's a lot of biomaterial and bioprinting, right? So we have tissue engineering, bioprinting, hydrogel, which is a technology used in bioprinting. Scaffolding, again, which is a technology used in bioprinting. We have 3D bioprinting, biomaterials. Microfluids, it's a little bit ambiguous what that applies to, but bioink definitely applies to biology. So, there's I don't think it's a more than half, but it's certainly a sizable percentage of the technologies are applied to biomaterials. Okay. I would also point out, when some of these technologies started kind of hitting their prime in terms of patents. So you'll notice that, for example, 3D printing was going strong even at 2009. Rapid prototyping, the same thing. But some of these other ones are relatively new. 3D bioprinting, we really didn't have patents until 2014. Same with bioink. All right. Now, fused deposition modeling, 2009, there was one patent. And you might be wondering, well, wait a second. Fused deposition modeling was invented by Scott and Lisa Crump with the Stratasys machines in the late 1990s. So why do we just have a patent right there for the first time? Well, we'll talk about that. That's very important to understand why some of these technologies that, have been around for a while, fused deposition modeling, stereolithography, FDM, which is basically the abbreviation for fused deposition modeling, why they're showing up kind of late on the scene, it seems like. All right, but we'll talk about that. But this is a chart that basically is showing the variety of technologies that are being applied to the 3D printing patent class. Now, just looking further at some of the trends with patents, the United States has a sizable lead in the number of 3D printing patents per country. Okay, China is second with less than half of the number of patents that we see in the United States. Europe is less than China, so on and so forth. Okay. And then if we get into the different, the owners of the additive manufacturing patents, these are the companies, right? The owners, if you're working for a company and you develop some new technology and you patent it, you're going to, at the very least, share that patent with the company that you work for. It's very rare that the company is going to give you full patent privileges because it's quite lucrative to have that patent privilege, and you're going to be developing a patent while you're working for a company. The company is going to want at least a share of that, if not all of that. But General Electric is one of the leaders in the field of additive manufacturing patents. HP, Hewlett Packard comes in second. Then we have United Technologies, Siemens, which is a German company, Boeing, which is an aerospace company. So this is interesting. Boeing does not develop 3D printers, right? They don't make any 3D printers, but they use 3D printers. They use, for the most part, metal 3D printing. So this really indicates that they're coming up with their own technologies and own processes for 3D printing the parts that they're going to be using in their airplanes. Okay, Xerox, Harvard University. That's pretty interesting right there. So this is the first university that shows up as in our list of top owners of additive manufacturing patents. Okay, and here's the two big boys on the block, the two originals, right? 3D Systems. That was the Charles Hull company that was started first, and then Stratasys was the company started by Scott and Lisa Crump. Remember, 3D Systems started with stereolithography, so a vat photopolymerization process, or resin process. And then Stratasys was started with fused deposition modeling, and which is a plastic 3D printing process, material extrusion. Okay? Now, just kind of summing up, giving you some numbers. Now, I had a hard time finding some numbers for 2020. I wanted to give you the most recent numbers that I could find because I feel like that is going to be the most applicable. There were 352,013 total patents granted in 2020. Okay. That's in total cumulative from the beginning of 3D printing. That's just not in 2020, but total over 352. There was less than a 1% decline in patents from 2019 to 2020. Now, the reason why I say that with some importance is because, remember, we just had the pandemic. And so you would expect that there was a decline in the patents. And we do see a slight decline in the patents, but it's a very slight decline, only 1% decline from 2019 to 2020. 3D printing was still the 9th fastest growing technology in terms of patents. Okay. And that's important because 3D printing, some people feel like it's its heyday was maybe 5 or 10 years in the past, but it's still, going strong. And the fact that it is the 9th fastest growing technology in terms of patents is pretty phenomenal when you think of all the things that are coming online now with self-driving cars and energy and the climate change and all that stuff. The patents that are coming out for that are going to be substantial, but 3D printing really holds its ground there with the 9th fastest growing technology. There was around slightly less than a 5% patent application increase from 2019 to 2020. And HP, Hewlett-Packard, has the most patents for 2020, and that was 470 patents they filed. Okay? All right. Now, let's get on to the real reason why patents are crucial in 3D printing and additive manufacturing. And that is because companies, people that develop these technologies. So I'm talking about the Charles Hull. I'm talking about the Scott and Lisa Crump. All those developers, they patented their technology. All right. And when they have the patent for that technology, then you can only buy those machines from those suppliers and manufacturers. Okay. So this is a list of the different additive manufacturing technologies and when their expiration date from their original patent filing is. All right. And why is this significant? Well, because this is the date when we would expect, remember that so for example, fused deposition modeling, patented by Stratasys and Scott and Lisa Crump, fused deposition modeling, the patent expires in 2009. So what that means is when you want to buy an FDM machine before 2009, you can only buy a Stratasys machine. After 2009, and if you're old enough, think back to that period, 2010 and on. After that period, that was when the explosion of 3D printing and 3D printers really occurred, right? Because you had all these companies now that were waiting for that expiration date. And as soon as 2009 hit, they were ready to go on the market for their own fused deposition modeling machines. All right. So FDM expired in 2009. That photopolymerization or the resin 3D printing process expired in 2013. Selective laser sintering, which is the melting of the plastic powders to form the object, expired in 2014, as did powder bed fusion, which was the same idea, except now we're talking about metal powders being melted together with a laser. Okay. And then selective laser melting, kind of another type of powder bed fusion process. We'll talk about the differences here, but those are basically metal processes. Selective laser melting, the expiration date was 2016. Okay, so these are substantial, and you'll note that after the year after these expiration date was when we had an explosion in terms of the industry, in terms of the market, with these technologies being now available by anybody and everybody. All right. So it's a good thing. It's a very good thing. So now let's look at some key patents. All right. So, these are some of the key patents that I just talked about. The key patent for stereolithography. And what I have here is this is the official title. This is what the patent is called. and then some patent information. And then this is one of the figures. I picked the most explanatory figure I could find, but this is one of the actual patent figures. So stereolithography. The patent was for an apparatus for production of three-dimensional objects by stereolithography. It was patent number 457-5330. Inventor was Charles Hull. Filing date was August 8th, 1984, and it expired in 2004, right? Publication date was 1986, but really the filing date is the critical date. What's the difference between 2004 and 1984? Well, 20 years. So this is a utility patent that was filed by Charles Hull, right? To basically start the whole 3D printing phenomenon or technology out. And it expired 20 years after the filing date, 2004, right? Now, this is the FDM printer, or the material extrusion printer printing, plastic. Though basically, this is the one that you're going to see at, Best Buy, Micro Center. You're going to be able to buy at Amazon. So this is the original patent for that. And the patent is called an apparatus and method for creating three-dimensional objects. That's this is a typical thing with patents. They have a pretty general, kind of title or name. They're written in such a way to kind of ward off people that want to copy the patent. So they write it very generally so that lawyers can apply it to anything and everything to kind of keep people away. But this is patent number 5121329. Inventor was Scott Crump. Filing date was August 30th, 1989. Publication date was June 9, 1992. And 20 years after 1989, it expired in 2009. Okay. This is one that just expired, right? And so it actually expired in February of this year. Okay. February of this year. But this is the patent for the heated build chamber, which was integral to the Stratasys FDM machines. Both of the Stratasys machines that we have in Moraine Valley in the 3D printing lab have heated build chambers. And it's crucial to printing the ABS plastic that we print with those machines. The title for this is High Temperature Modeling Apparatus. So again, very general title. The inventor was, actually the patent lists a whole bunch of names of the inventors. These are employees of Stratasys. So Stratasys actually owns the patent. It was filed on June 23rd, 2000. So 20 years later. I think they had, I think they had a little bit of an extension. And so it actually expired in February of 2021. So they might have had a slight extension on that. But the publication date was 2004. Okay. And this is what the figure looks like. And so that leads us to, the advent or the kind of explosion of the consumer FDM or, plastic 3D printing marketplace, right? The expiration of the FDM patent in 2009 resulted in the consumer 3D printing industry explosion. So we really wouldn't be having this class, and you wouldn't be able to print things at home without the expiration of that patent in 2009. It resulted first in the development of a 3D printer called the RepRap Mendel in 2009. That was really the first non-Stratasys 3D printer that hit the market. It also represents the founding of MakerBot. This is the first MakerBot right here. MakerBot was named MakerBot because you would put it together yourself. So you got all these parts, and then you assembled it yourself. So it was kind of an interesting take on that. You can still buy MakerBots. I'm not sure. I don't think you can buy RepRap Mendels. I think that company was bought out, but actually no, I'm wrong. This is the MakerBot, right? This is the RepRap Mendel. Okay. All right. So let's continue on. The key patent for the selective laser sintering. The title is an apparatus for producing parts by selective sintering. The inventor for that was Carl Deckard. He founded the SLS, or invented the SLS process. The filing date was May 30th, 1994, and it expired in 2014. And so in 2015 and beyond, now we can buy many, many different makers of these selective laser sintering machines. So some consumer selective laser sintering machines that have now come on the market. We have the Sintering, right? This is a company, Sintering, that's based in Switzerland. They use a nylon powder. Remember, SLS is for plastic powder sintering or melting together. It uses a compact diode laser to apply the heat to melt the powders together. It costs around $5,300. And by the way, they've come down greatly from that. That's one of the effects of the commercialization, the marketing of 3D printers after the patent expires, is you now have competition. And so competition drives down cost, right? We also have the Polyforge, which is another one. It was invented by a gentleman named Patrick Lai in California. It uses nylon powder, 20-watt CO2 laser to apply the heat, and it costs $10,000 to $20,000, which is very expensive. But remember, at this point, the only competition they had was the other SLS machines developed by Carl Deckard. Okay, so that was their only competition. And as I said, since that time, they've come down. I'm not going to play these videos for you. I'll put them on Canvas so that you can watch them yourself. Now, we have some more. These are interesting because the one on the left is an open source laser sinter machine, which basically means that they give you all the gentleman that developed this, Lucas Hopp, is based in Germany, and he basically developed it and then gave away all the plans for it. So you can actually build this yourself. Store-bought materials. It doesn't require anything very special. I've downloaded all these, all the plans for this. So if you want to see it, I'm not sure that internet address u-sls.com still exists. But if you're interested in that, I've downloaded all the plans for that. And then we also have the ShareBot Snow White, which is based in Italy. It uses nylon powder and other CO2 laser. It costs around $22,000, and then there we go. Now, these companies are from probably 2018. So as I said, this industry moves very fast. So it might be that ShareBot doesn't exist anymore, that it was bought out by another company, a larger company, or that the company just couldn't sell enough of these machines, and so they went out of business. That's another consequence of kind of the Wild West when the patents expire. All right, so let's continue looking at patents. We have the sheet lamination patent. Remember the LAM machine. So the title for this is an apparatus and method for forming an integral object from laminations. The inventor was Michael Fagan, and the filing date was 1987. And so 20 years after that, in 2007, it expired. Right? Binder jetting is the last one we're going to look at here. Binder jetting. The title of the patent is a three-dimensional printing techniques. That is about as general as you can get. Three-dimensional printing techniques. Right? The inventor was Emanuel Sachs and others. Its filing date was 1989 and it expired in 2009. Now, binder jetting, we haven't really talked about that. Binder jetting is a technology where, again, it uses powders, kind of like selective laser sintering and powder bed fusion, where we have plastic or metal powders. But instead of using a laser to melt the powders together to form the object, binder jetting uses a spray adhesive. So you're spraying an adhesive on the powders in a very, very controlled manner to glue the powders together. Usually with binder jetting, there's a secondary process where we have to kind of, heat up and further solidify the powders as they're bound together in a couple of different technologies, depending or processes, depending on whether you're using metal or plastic powder and whatever. We'll get into all the details about that, but this is the last key patent that we're going to talk about in this presentation, binder jetting. Okay, so the last thing I'll say about this is that we are benefiting from the expiration of these patents, right? The patents were developed by brilliant people. They brought all this technology to the forefront, but really the expiration of the patents resulted in the explosion of 3D patents, 3D printers, both in the powder, resin, and metal technology formats. And it's really the reason why we're talking about this right now. All right. So thank you very much. I'll see you in the next lecture.